All right, let's talk about the real command center of your body. Tucked away deep inside your brain, there's this tiny little setup that's basically running the whole show. Everything from how tall you grow to how you deal with stress. Today, we're going to pull back the curtain on this incredible power duo, the hypothalamus and the pituitary gland. So, who do you think is really calling the shots in your body? I mean, really. You might guess it's your brain, the part that's doing the thinking, right? Or maybe your heart? Well, the truth is, the real power is held by something way smaller and a lot more secretive. And here it is. The answer is a powerful partnership that's literally no bigger than a pea. I love this analogy. Think of the hypothalamus as the CEO of your body, the one with the grand vision. And the pituitary gland, that's the general manager. It takes the big ideas from the CEO and turns them into actual orders for all the employees, the rest of your body. Okay, so this dynamic duo together is what we call the hypothalamus-pituitary axis, or the HP axis for short. And this isn't just some minor department. Nope, it is the control tower for your entire endocrine system. It's the most dominant, most complex part, guiding pretty much everything. And just look at its job description. The HP axis is managing your thyroid function, your adrenal glands, and stress response, your growth, lactation, even something as basic as your body's water balance. I mean, the sheer range of control from something so tiny is, well, it's just incredible. So how did this powerhouse get built in the first place? Well, the origin story of the pituitary gland is actually fascinating, and it's the key to understanding how this whole command center really works. It pretty much explains everything. Okay, get this. It's like a tale of two totally different tissues. When you're developing, a little piece of tissue from the roof of your mouth starts growing upward. At the exact same time, a little piece from your developing brain starts growing downward. And then they meet. They fuse together and become one single gland. It's just this amazing feat of biological engineering, right? And that wild origin story is so important because it created a gland with two completely different parts. The part from the mouth became the anterior pituitary. It's a true gland. It actually makes and secretes its own hormones. But the part that came down from the brain, that's the posterior pituitary, and it's basically just an extension of the hypothalamus itself. It doesn't make hormones, it just stores and releases hormones that the hypothalamus produces. All right, so we've got our CEO, the hypothalamus, ready to give orders. But how does it get those memos to the general manager, the pituitary? Yeah, it's not just sending a company-wide email. It has its own private messenger service, a kind of VIP delivery system. It's this special network of blood vessels called the hypothalamic hypophyseal portal system. And what this does is it lets the hypothalamus send these super concentrated chemical messages directly to the anterior pituitary. The signals don't get all watered down in the main bloodstream. It's a brilliant design, making sure the message arrives loud, clear, and potent. And here's a look at the actual memos. You can see the different hypothalamic factors here. Now, some are releasing hormones. They're basically the gas pedal, like GHRH, which says, go, release growth hormone. But then you have inhibiting hormones, which are the brakes. Somatostatin, for instance, tells the pituitary, whoa, stop releasing growth hormone. It's this beautiful push and pull, this gas and brake system that gives the body such incredibly precise control. Okay, so the memos are in. The general manager, our pituitary gland, has its instructions. Now let's look at the orders it sends out to all the other departments in the body. Let's start with the easy one, the posterior pituitary. And remember, this part is basically just a storage closet. It doesn't manufacture anything. The hormones it releases are actually made up in the hypothalamus and then sent down for safekeeping, just waiting for the signal to be released. And it's really holding on to two key players. First up is ADH, or arginine vasopressin. This is your master water regulator. It's what tells your kidneys, hey, hold on to that water. Then there's oxytocin, which is famous for its role in labor. Its name actually means rapid labor, and for the milk letdown reflex. Two very important jobs. Okay, now for the main event, the anterior pituitary. This is the busy factory floor. Its hormones fall into about three big families. You've got the ACTH-related ones for handling stress, then the glycoproteins, which talk to other glands like your thyroid and gonads, and finally, the somatomamotropins. That's where we find heavy hitters like growth hormone and prolactin. Now, prolactin is the odd one out here. It's really unique. See, most hormones are waiting for the hypothalamus to hit the gas pedal to say, go. But prolactin is different. The hypothalamus is constantly hitting the brakes on prolactin, using dopamine. The only time prolactin gets released is when the foot comes off the brake. So it's a system that's always ready to go, but it's held back on purpose.
But what happens when this perfectly tuned system fails? With a command center this powerful, any breakdown in communication can have some pretty dramatic consequences. Let's take a look.
Let's start with that water-regulating hormone, ADH. If you have too little of it, your body just can't hold on to water. That's a condition called diabetes insipidus, and it leads to extreme thirst and, well, a whole lot of urination. On the flip side, if you have too much ADH, your body holds on to way too much water. This dilutes the sodium in your blood to dangerous levels. That condition is called SIADH. So you can see two completely opposite problems, all from one hormone being out of whack. Or how about growth hormone? With this one, timing is absolutely everything. If you get a flood of excess growth hormone before your growth plates close as a teenager, the result is gigantism. You get incredibly tall. But if that same excess happens as an adult, after those plates have fused, you get acromegaly. The bones can't get longer, so they get thicker, leading to enlarged hands, feet, and facial features. It's the exact same hormone, but the timing completely changes the outcome. And remember prolactin, the hormone that's always on brakes? Well, what happens if you cut the brake line? If something, like a tumor or damage to that pituitary stalk, interrupts the dopamine stop signal, prolactin levels just shoot through the roof. This is called hyperprolactinemia, and it can lead to things like infertility and even lactation when someone isn't pregnant. So the takeaway here is pretty clear. This tiny little axis, this command center that's no bigger than a pea, has this absolutely massive impact on our health. I mean, from our height to our stress response to our basic internal balance, it's all being run by this incredible CEO and general manager partnership. So I'll leave you with a little thought experiment. Think about everything we just covered, especially how the two parts of the pituitary are so different. What do you think would happen to those posterior pituitary hormones, ADH and oxytocin, if you were to sever that physical connection between the hypothalamus and the pituitary? It's a question that really gets to the core of how this whole amazing system is wired.